Hey guys, welcome back. This is part 2 of developer machine, and in this part we will escalate our privilege from the car user to the root user. Before going to that, just wanna revise one more time what we did in the part 1. So in the part 1 we have a CTF web application where we put the write-up after solving a challenge. Then with that write-up we actually find out that there is a chance to set up a phishing attack, and we did it with the tab nabbing. After tab nabbing, we actually got the credentials, we logged in, and we found the Django administration portal. We logged into that and we find a user Jacob, and we actually got one more subdomain in the same Django portal. Then we logged in with that portal and we found that there is Sentry web application and the version is 8.0.0. When we go and search for the Sentry vulnerabilities, we found that authenticated remote code execution is there. So we exploit that remote code execution and we got the web shell for www data. Then we find out the database strings and after login to the PostgreSQL, we found the hashed password for the Carl user. We crack it with the hashcat and we got the credentials for the Carl user. Now when we got the credentials for the Carl user, we can simply go and make SSH for Carl at developer.hackthebox and just copy this, come and paste it here. And we are logged in. Now the way to root is if we go and run sudo space -l command and just paste the password again, we will find that this binary can be executed with the Carl user as root with the sudo. So if you want to see what privileges Carl user have, so Carl user can read and execute this binary. Also, why I call it binary or executable, because if you go and see with the file command, you will see that this is ELF 64-bit LSB file and the version the platform supports is x86-64 version 1, and this is the information for the interpreter. This is the build ID. So that's been said, I already actually copy this binary to my local machine because I also tried for the buffer overflow, but that doesn't work and this is not the way to solve this. Before going to that, I actually want to show you by executing this file. So a binary sudo and paste it here. So as you can see, welcome to the CyberGreek super secure login portal, and we need to put the password. So any password you put, it is going to say you entered a wrong password, and buffer overflow does not work. So maybe there is something in this binary. A lot of time I found that in the binaries there are already a password that is hard coded or the hashed, and once you type the password, it is going to encrypt that password and going to match with the hashed value which is already written in the binary for as the correct password. So if your password hash value is equal to the hash password already written in the binary, it is going to authenticate you. So I'm thinking something like this is going to be happened with this. I'm going to use GDB. This tool I'm going to use, and authenticator. Okay, so GDB authenticator, and with the GDB actually I am going to use PWNDBG GitHub. So if you are using PEDA or something else, so there is no much difference, but you just need to have the mindset, and you just need to have an idea that how you can go for the reverse engineering on this binary. So if you want to use PWNDBG, you can go to that GitHub link and then just clone this repository, then go to that folder, and you just run. You just need to execute the setup.sh file, and it will automatically install all the dependencies, and it will automatically set up everything for you. So come back here, and yeah, we have the PWNDBG. So clear not work. So I'm just going to start here. The most important part here is this section belongs to registers. You can see RAX, RBX, and RCX, RSI, R8, R9 up to R15, then RBP, RSP, and RIP. So these all the registers. So this second section is for disassembly, and this third part is for stacks, and this last part is for backtrace. So okay, we start debugging and we come here. We can see that this is the first breakpoint on FD0. So the next breakpoint I am going to set on this call function. So let's just copy this and B star and paste. So hit enter, and you can see we set the second breakpoint here. Now I'm going to continue with this breakpoint, then step into that breakpoint, this breakpoint. So for step into this breakpoint, we need to put S and hit enter. We come into that breakpoint in that function, call function. Then I just need to go next until we find something interesting or any function that is interesting to us. Also, on each function or on each breakpoint, when we go through with that, we need to also see these registers, if these registers have some values or not. So just like next and next, still we have here nothing interesting. Actually, we will go up to the point where this executable will ask us for the password. So, and as you can see, in this point it is asking for the password. But if you see here, before this part, we can see there is one more call function, and this is the value. So I'm just going to copy this, and 1 2 3 4 5 6, anything you want. So I just want to delete rest of the breakpoints, whatever we said before, and now I'm going to set new breakpoint, that is where is the call function? Yeah, this one. So hit enter and run it again. So as you can see, this time we directly come to the currently set breakpoint. So we do not always follow from the beginning, from the scratch. So we directly come to the breakpoint what we said before. Now we just need to continue with that. Okay, so run again, df0, and step into this function. Okay, and we go to next, sys common backtrace rest begin short backtrace. Okay, and this is also a call function. Delete all the breakpoints and then set new breakpoint on this. Or let's go just follow with that. So copy and paste here, hit enter, run again and step into that. So as you can see here, we are in that call function, and just we need to follow next. And before going to next, if we see next, okay, this is the call function, that is the next call function, as you can see here. So once we go next, we will actually come to that function, call function. So this time we are going to set breakpoint on this. So delete rest of the breakpoints and set the new breakpoint on this B231. Yep. Hit enter and we have set the breakpoint. Now run. So you can type the complete command run or just R. So as you can see, we come directly to that. Now we go into that function, into that call function, and we are inside that call function. Now there is no call function, so we are going to make next and next, until we find call function or something interesting. So there is a call function which contains the which is calling the value for RBX, and in RBX there is nothing much interesting, so just go next, 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 next again, okay, so there is a call function here which calls the value for RIP. Just go until we found the point where the binary is asking for the password. Here you can see this call function is interesting for me. Why? Because it is now in that part, in that function, it is reading the file stdio stdin. So I'm going to set the breakpoint on this point, but let's go first see and we come to that call function. Let's see what's next. So as you can see, it is going to compare the value. So let's just set the breakpoint here. I'm going to set copy, delete all the previous breakpoints, set new breakpoint 876, yeah, and just run this again and step into that function. We are in that function, so S, and we are inside that call function. So now in this call function, just make next, 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 authentication main, any call function. There is one more call function, it's allocating, and you can see here also in the register, you need to keep an eye on the register also. You can see there is no values. These registers, it contains no value, right? Just move on from here, next, next, next. Until now we did not find anything. Sorry, just single n, 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 and this is what I need. So as you can see here, first of all, this is a call function, and second thing is it's a crypto function or cryptography thing is going on that call function, and the algorithm is AES, which is using CTR. Fine. So the breakpoint I'm interested to set on this. So delete all the breakpoints and set a new breakpoint on this. So hit enter, run again, and as you can see, we have, it's asking for the password. We set the password, and as we set the password here, if we see this part, we find there is something. So this value coming to RCX, and this is already here, and the interesting part is RSI also contains some value. So in this call function, I want to check the hex value of these registers. So just say hex and dollar and RAX. So RAX, and yeah, it contains some value. So the value is actually start from FE and continue. You can see it's keep changing. So this is actually the valid value up to 2C, because after 2C you can see a bunch of 0000 and 5555, something like this. Okay, so next is we are going to see the value for RCX, because RCX contains some value here. So RCX, and as you can see, it also contains something from 76 to 6A, because after this you can see a bunch of zeros, and this is not containing values here. Next we have RSI. It is also having some value now. So RSI, hex value of RSI. So this is also interesting because you can see it contains two values. It contains, actually this is the unique value, and as you can see here, RCX, the value of RCX also with the RSI. So I think if we go and open the Cyber Chef AES, go inside here. So the first thing you can see, it's using AES with the CTR. So the mode we need to choose is CTR. Now there are three things. The first thing is key, second thing is this value 4, and we need to put input and we will get output. If we see these values, so I'm going to actually copy these values. So copy this, and I am going to put here. Second value is this 76 up to here. Copy, paste that here, and this is the third value which comes, copy, and this value is actually in continuation from here up to here. So from here up to here, 2C. So take this value also, copy and paste it here. So this is in the continuation. So I think this is going to be the input in the hex form, because you can see FE1B25, this is hex. This is also hex and this is also hex. So one thing is confirmed here, that everything here is hex. So just set it hex, and this is already hex, and the mode is CTR. Input is in hex because this is maybe the input, and this is also in the hex form. And output, let's set raw. So once we get the output, we will see we need to change it into the hex or into the raw. But these up to here, key, this 4 value CTR, and this input value is in hex. So for the input, I'm just going to copy this, paste it here, and this is value for this, and this is gonna be the key. Let's see if it is correct or not. And we got the password for this binary authenticator. So as you can see, this makes sense. Rust for security at developer at 2021, and this is some smiley, whatever is that. So that makes sense. But if we make this output into hex, so you can see we will get the hex output. If we put it into the raw, so we will get the correct value. So it means this is the key, fine, and this is 4, and this is input, and the encryption algorithm is AES with CTR. Save it, and now we have the password. So just copy this password, and we can say output is this. Now go back to the Carl and let's run again the binary with sudo, and the password for the Carl user, we have it here. Just copy this and paste it here, hit enter, and we need to put this password now. So up to here, copy and paste that selection, hit enter. As you can see, you have successfully authenticated. Enter your SSH public key now. So we can have our public key, exit now, quit, yeah, clear, and cat, then in the home directory .ssh /id_rsa.public key, hit enter. This is our public key. So just copy this, go back here, paste that here, and as we paste, you can see you may now authenticate as root. So just from here we can make, or go here, no problem, clear ssh root at developer.hackthebox. Come on, yeah, we are root. That's fantastic. Who am I? ID and host name. So as you can see, we are root. This is our ID and the host name is developer. Now if I make ls space -la, so you can see we have the root flag here, and that's it. So this machine is really fun, and I actually like this machine because the way it is set up, that is fantastic. So hope you learned something new. If you like the video, if you like the content, please like, subscribe and share as much as you can. See you in the next video. Bye.